Alright, so today we're going to create a Eratosthenes sieve to learn about the fork, dupe, and pipe system calls. So first of all, what is an Eratosthenes sieve? Well, it's a way to find out way to calculate the prime numbers. So for example, let's say we pass in a bunch of numbers. Let's start from 2 because we just know that's the smallest prime number. So we'll pass in 2, 3, 4, 5, 6, 7, 8. You could do it to infinity or whatever. And then the first process will pass in those numbers. And then the second process will say, okay, let's take that first number in the input stream. Let's take that, let's print that out to the screen. And then for all the subsequent numbers, if it's not divisible by 2, well, let's pass it on to the next process. So here we're passing in 2, 3, 4, 5, 6, 7. We print out 2. 3 is not divisible by 2. And so we'll pass that in. 4 is divisible, so let's just get rid of that. 5 isn't, 6 is, and 7. So then we end up passing in 3, 5, and 7 to the next process. And so then the next process does exactly the same thing. It takes in the first number. It looks if for each subsequent number, we can call it n. If it's not divisible by 3, let's pass it along. And in this case, we know that neither one of them is divisible by 3. And so we'll pass it on. Process 4, we'll do exactly the same thing. And so it'll say, okay, well, let's print out the first number, which is 5. For all subsequent numbers that aren't divisible by 5, let's pass them along. And 5 prints out 7, and yada, yada, yada. And then finally, okay, there's no more numbers to process, let's just quit. And so that's the idea. It's not a particularly efficient program in the sense of, well, to calculate 100 primes, you need 100 processes. But that's fine for right now. Let's not worry about that so much, because it's sort of an interesting program to learn about how processes work and pipes and how we can communicate between processes. And so the problem is it's really simple. Like, okay, one process passes things on to the next, But normally what happens, let's say, like how does one process create? First, how does one process create another process? And then how does that first process communicate with with the second process, or and sometimes these are called, or oftentimes we could call this the parent process, the child process. And so the parent process will create a new process, and it'll be its child. So let's process 1. Let's take a look at what actually is a process and how we can create another one. All right, and so let's just take a snapshot of a process, simple process. Right now, it's not doing anything at all, but we have a process started up, and associated with each process is this thing called a file descriptor table. And so what is that exactly? Well, it's just a table, and each index of the table points to, or if there's something in it, points to a related file. So for example, the index 0 will point to this standard input file, and that's just like that's normally just getting input from the keyboard, and then that goes to a buffer, and then there's your standard input. And then index 1 of the file descriptor table just points to standard output, buffer, and then it just goes to your screen. And standard error, which is at index 2, index 2 points to a file, standard error, and it just goes directly, it just prints out directly to your screen. There's no buffer involved. And that's a big oversimplification, and it might be incorrect, but I hope not, but maybe. But that's generally how it works, or how I've been thinking about it. And so let's say we then create, and so how can we create another process? That'd be with the fork call. So this process 1 could just call fork, and what happens there? Let's get rid of that process descriptor. All right. So, and then let's hide that in there. All right. So, this process 1, when fork is called, an exactly identical process will be created. It's weird. It is how it is. It's exactly identical. Right now, the process 1, it calls fork, and then we have a process 2, and it's exactly identical. It just creates the file descriptor table is the same. They're both going to the same inputs, outputs, and standard error. And so the problem is, so let's say, for example, we were in process 1 and we passed in a stream of numbers to output. What would happen? Well, it would just the standard output is in index 1, and so if we wrote to that index, it would just go to standard output and go to the screen. And well, that wouldn't really help process 2 at all, because it would very much like to get those, and well, and so there's right now there's no way for these things to communicate. And let's say, for example, that process that we create a pipe. Let's say in process 1 now we're like, okay, we want to communicate with process 2. Well, let's create a pipe. So a pipe is just, and that would be with the pipe function call. All right. So let's say process 1 calls this, we can call this the parent process, actually. Parent process. and we'll call this the child process. Child process. So it calls pipe, and it passes in these an array, an array just to hold the file descriptors. And so pipe will automatically see that 3 and 4 are the lowest empty file descriptors, so it'll assign 3 and 4, and we have to have some way to hold that information, and we can hold it in an array, and then we can know what it is, because it could be 8, 10, and the process wouldn't really know, like we wouldn't really be able to get that information without storing it in an array. And so that just gets what that would look like in code is, so for example, we have some main process, and so here this would be considered the parent process, and we could have int pipe, no, let's just call it PD and 2. So now we've created an array of two integers, and then we can create pipe process descriptor. And so now we get a little bit of an error here saying pipe is invalid. That's because we don't have the right man to pipe. So we want to include uni standard there. So I never really can remember any of those, but anyways, you can just use the man pages to get it, and this will give you a bit of a description of what happens. And so the pipe creates a pipe and allocates a pair of file descriptors. The first descriptor connects to the read end of the pipe, and the second connects to the write end of the pipe. And so those file descriptors will be stored in this array, PD, and we have a pipe, and so then so now, oh no, process 1, file descriptor table, there. And so now we have these pointers. So 3 is the read end of the pipe, and it's pointing there, and 4 is the write end of the pipe. And so you might be noticing something wrong here, and if you are, that's good, and if you're not, that's fine. But we have this pipe. We created a new process, and then we created this pipe. And so the problem is this pipe isn't connected at all to the child process, and the child process has no information regarding this pipe. Let's look at that in code. So for example, what did the parent process called fork, and that creates a child process. So we can say if fork, and this is the parent process, and else, and this would be the this would be the child process, or if an error happened, it would go in there. And so why is that? Let's look at the man pages. Man to fork. And so upon successful completion, fork returns a value of 0 to the child process and returns the process ID of the child process to the parent process. And so, well, that's going to be, so if we're in the parent process, the file ID, the process ID, I should say, of the child process will be passed to fork. Otherwise, it will be 0. Otherwise, it'll be 0, and we'll just ignore the errors. Otherwise, a value, and if there's something wrong happens, a value of -1 will get returned, but we'll just ignore those errors for right now to make things a little bit simpler. And so let's actually just say that's the parent process, and right here is the child process. So because obviously if 0 is returned and we're in the child process, that would be false, and otherwise, and so we go to the child process, and otherwise it would return true, and we'd be in the parent process. And so in this parent process, we then and then in this parent process, we created a pipe. And there we go. We created a pipe. But the problem is this child process has no information. It has no knowledge that a pipe was created, and it can't. It's well, this parent process could write to the pipe. It could still say, let's write. You could say, let's process descriptor 1. You could write, well, you could write an int. Let's say int test equals 5. You could write, test size of int. So the parent process could write to that, and it could also read from it, and then you could just say, well, we're done writing. You could close process descriptor 1, and then you could int output. You could then read from it, read process descriptor 0 at, let's pass that to the output, and size of int. So these read and write commands, very simple. It's just saying we're going to write to, what file descriptor will we write to? Well, we know it's stored, the right end is the index 1, and the read end is at index 0. And what are we going to write? We're going to write 5, and that just gets passed. We just get a pointer to test. And how many bytes are we going to write? Well, we're going to write the number of bytes that is an integer, and that would be 4. But it could vary, and so we can just say size of int. And we're going to read, and then we could close that. It's really important to close that. once you're done writing. And then you can read the output, and then you can read from the read end of the pipe, and you could output that to output, and then how many bytes do you want to read? Same thing, you want to read 4 bytes or the size of an integer. And let's printf output, and what are we gonna output? And then we're standard. Let's just include standard IO, and there we go. And let's gcc primes.c. Let's see, what do we get? Output is 5. And if you want to, and so what happened there is, if we look at our diagram, what all we really did is we wrote 5 in there, and then that we read 5 from there, and then we send it along to standard out, and it showed up on our screen. And woohoo, that works. But once again, a little bit useless, because this process had access to that integer anyways. It was really not super necessary to create a pipe, and so, I mean, you know, it's fun, you know, you get something goes in, something goes out, but well, it's just an extra step that's not necessary. So let's undo that. Let's get rid of all that. It's not really helping us. We did something wrong, and so what did we do wrong? Let's get rid of process 2. Table. Let's get rid of that. Let's get rid of the pipe call. Let's get rid of the fork call. There we go. Perfect. All right, so here we go. Let's get rid of that pipe as well. Perfect. So now we are, and let's get rid of that child process. Perfect. So now we're back at the beginning, and here we go. So the key intuition here is that we want to have to create that when we create the child process, it'll be identical. So what we can actually do is, in process 1, we could actually create our pipe. We could create a pipe, and boom, boom. All right, so that's cool. So we have this parent process. Well, we could even just call that process 1, because, well, it's the only one. And right now we have a write end of the pipe, a read end of the pipe. We have all the information, and then after creating the pipe, so let's go back to our editor, and so let's say int process descriptor. Let's create an array of 2, and let's pipe. There we go. And so there we go. We created our pipe, and now that we've created our pipe, we can fork. We can do the same thing. If fork parent process else child process. And so what does that look like now? So that's, well, let's make there. It'll have that file descriptor table, but we'll have some additional information. The array, since it's an exact copy, it'll have that. It'll have it'll have that in the process descriptor, the PD array. And then it'll also have the file descriptor table is the same. And so right now we have a pipe, now we're able to communicate here. So for example, let's say I want to say let's say I want to write pass some integer to the child. So I'm in the child. I want to write, let's say I want to write, where are we going to write to again? So in the parent process, let's call that parent process, child process. Perfect. So what are we going to write? Let's write 5 again. Write, no, sorry, where we're going to write it to? We're going to write it to PD1. And let's write an integer. Int from parent equals, let's say 5. And there we're gonna write it in there, and let's pass in from parent and size of int because it's an integer. Okay, and so now some things to notice though is we're just writing from the parent's just gonna write to that process. It's not gonna be read from it, so it's good practice to close that read end of the pipe. And so what does that do? What does that do? So if we close in, let's close in that read end of the pipe, read end of the pipe. Now 3 is it's not pointing towards anything. But it's still, the read end of this pipe is still open. It's just closed for the parent process. Since we're not going to be reading from it, it's there. And then we also want to, after writing, we want to close there. And so what does that do? Boom. So now it's not going to be able to send or receive data from the pipe. And that's fine. We aren't too worried about that because it's no longer necessary. And then the child process, well, it just has to it still has access, so the child process won't be writing to the pipe. So let's close process descriptor 1. So boom, let's close process descriptor 1. There we go. No longer, so now that end of the pipe is just closed. Nothing can be written to it, but there's still some information in there that we want to get. So let's let's actually call this toParent. Let's call this toChild, really. toChild. So this is some 5 we're getting sent to the child. And let's call it from parent. Okay, and let's read from that process descriptor, the read end of the pipe. What are we going to be reading? Or where are we going to be writing what we read to? Well, let's just write it to from parent. And what's the size? Size of int. There we go. And now let's close the read end of the pipe. Okay, and then we can, let's print out from parent, printf from parent and from parent. There we go. And let's see if that works. GCC primes.c. Perfect. And then, so the parent process sent to the child process. And so what about if we wanted to and so that's how it works. Fairly simple, but what if we actually wanted to like to actually just write to standard input? What if we wanted to, could we redirect standard input to the read end of the pipe and redirect standard output to the write end of the pipe? Well, the answer is yeah, we can do that. And so, for example, that's fairly easy. Let's keep this going. Let's not worry about that. All right. And so we've set it up. We've set everything up. We have a pipe. We got all that stuff going. And I forgot to add that fork call, sorry. And file descriptor table. Boom. There we go. And so how can we redirect this redirect this input? All right. So what we can do is we can use what's called the dupe call. And what that does, well, let's look at the man pages. Man to dupe. So what it says is it duplicates an existing object descriptor and returns its value to the calling process. The argument file descriptor is a small non-negative integer index in the per process descriptor table. And so of key importance here is the new descriptor returned by the call is the lowest numbered descriptor currently not in use by the process. And so that fact we're going to take advantage of. And so we can just close. If we're in the parent process, we can just close. We're going to be writing to. So let's think about this. What do we want to do exactly? We want to take this, the right end, we just want to whoop, yada, 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 boom. That's what we want to do. We just want to direct that over to that right end of the pipe. And so how do we do that? Well, it's not super hard. So let's just first close standard output. Boom, it's closed. And so we can just get rid of that. It's closed, there's nothing in there. And so, but 0 is being used, 2 is being used, 3 is, but 1 isn't. So if we then dupe process descriptor, the right end of the pipe, what's going to happen? Well, it's then just going to set it's then just going to create let's create a shape. Let's get an arrow going. It's just going to point to that right end of the pipe. Easy peasy, lemon squeezy. And so for example, duplicate, and now if you'll notice, this parent process has two file descriptors pointing towards the right end of the pipe. And so it's good practice then just to close process 1. And so that just gets rid of, boom, there we go. Now we just have one thing pointing to it. Standard output is not actually going to standard out, it's just going to the right end of the pipe, if that makes sense. And now let's write. Where do we want to write to? Let's try this out. Let's write to 1, which is normally a standard output, but we're redirecting that. And what are we going to write? Let's write to child, and let's size of int. Perfect. And now let's just close that right end of the pipe. Close 1. There we go. And now in the child process, int from parent, we can just read. And what are we going to be reading? We are going to be where are we going to be reading from? Well, not standard input, because we haven't redirected anything there. We are just going to be reading from the read end of this pipe. And we can also just close the right end of that pipe. Let's do that first. Close process descriptor 1. And so there we will close that process descriptor 1. That should be that one. And okay, now look at this. I forgot to close something. I forgot to close that read end of the pipe in the parent process. And remember, we weren't doing ever using that, so we can close file descriptor 0. oh no, sorry, process descriptor 0. There we go. And now that is, boom, closed, wait. Closed, boom. So now we just have to read, I accidentally closed that, fuck. There we go. Now we can just read from that pipe that we wrote to, read process descriptor 0. Let's write that to from parent size of int. And then let's close process descriptor 0. And let's print f. And so we can still, in this child process, we can still write to the standard output. We haven't redirected it in the child process. It's still all fine and dandy. So let's printf from parent n from parent. And so let's see what happens. And if I made a mistake or not, gcc primes.c, gcc primes.c, and boom. What do you know? And so we can then actually just redirect this standard input in the child as well. So let's do that. So we can actually just close the standard input, which is 0. And so then that, in that file descriptor, will, boom. No, that's process 1, sorry. Boom. That's not pointing to the standard input anymore. And then we can dupe file descriptor 0, process descriptor 0, and then we can, there we go, and then we can close process descriptor 0. And so what that will look like is we will have on the standard input for process 2, it's just going to the read end of the pipe. We close that end of the pipe and boom. And then we could just, let's try running this program again, see what happens. But remember, we didn't change where we were reading from. So let's see what happens. gcc primes.c and then a.out. Alright, so it got 0, right? It's nothing was really read. 0 is just the default value. And so, well, okay. But if we are instead reading from our standard input, what this child process believes is its standard input, but we redirected it, we can gcc primes.c, boom, there we go. We are getting that value. Yay, that is fun, I guess, somewhat. Okay, and so that's how we can just redirect. And so what would happen? And so why you see that I keep closing, making sure to close all these file descriptors and everything like that. Why is that even necessary? Well, let's say, for example, that that we tried to then read, and actually I didn't even close 0. Let's say before closing that, I want to read again. Read from 0, we'll just put it at the same place. I think it was from parent size of int. Woo. And so we're just going to read from there twice. And no, that's a bit not necessary. And we don't actually, in the parent process, we don't actually close we don't actually close that right end of the pipe. What's gonna happen? What's gonna happen? GCC primes.c dot a dot out. Fuck. Why did that print out? Read from parent. Why did that? Why didn't? Let's actually wait. No. Let's mean to wait. I believe this is what's gonna. So we're just going to see. Sorry. So for example, I added this wait call, and what does that do? That just says, let's just wait until exiting. Wait here until the child process is finished. And then we have this additional read call. And what's happening there? And so then we're just saying, we know that there's nothing to read, but it doesn't know that. And the problem is we haven't closed the right end of the pipe. And so what happens when the program just hangs. Nothing is happening, and why is that? Well, we didn't close this right end of the pipe, and so it reads that. That's fine. We could even print that out. We could even just print that out right there, and that should get printed to the screen. But then we come to this read end, and the read sees that the pipe isn't closed, and so it just waits there. It's just waiting there, and so nothing happens. The program just hangs. Let's run it. Let's run this version of it. So from parent 5, that prints out fine. No issues there. But what's going on? That's not good. But again, we close that pipe, and from parent gets printed out fine, and we return, and then we could even print it out again. sorry, we could even print it out again. And there, from parent, it gets printed out 2 times. Well, that's fine, but nothing was actually read there. Nothing was read. And so that's sort of a little bit misleading. So let's just delete that. So as you can see, it's really, really important to close those pipes, because otherwise you can the program might just hang, and it'll be sort of hard to figure out why exactly. And the only real way to solve it is just, well, closing the appropriate pipe. And so that's why it helps drawing these diagrams. And so those are the main processes that main functions that we need to know. And so now let's see if we can start writing out this what do you call it? What's this guy's name? This Greek guy's, man, dude. You just know, reading that name, that dude was smart. Eratosthenes. That anyone with that name is gonna be a smart dude. Like, yeah, that's. But anyways, okay. So let's start writing out this program, and so we can also use. Let's just do this from scratch here. Let's just return 0. And so there's some things that's going to happen. We can just have void. We want to pass in this process 1. Process 1, we want it to just write a stream of numbers to the output, right? And so we know we're going to be redirecting that output. We're just going to be redirecting that standard output to the right end of that pipe, and we're going to read the standard input from the read end of that pipe. And so we can just write a function that looks like void source, and we can even have it take in, let's say n. We want to find all the prime numbers up to n. And so we can just say for int I equals 2, I is less than, let's say less than or equal to n, I plus plus, and we are just going to write to the right end of the pipe standard output. Well, it's not going to be standard output. We're just going to write to the right end. What this right now we think is standard output. We're going to be redirecting that. What are we going to be writing? We're going to be writing whatever I is and size of int. And boom, let's make that all standard. And so there we go. There's our, so now we have, in how it works, we just have this process, it'll pass in some numbers, and there we go. And what's another function we might want to be able to, we might want to redirect, void redirect, we'd want to redirect int, let's say file descriptor, and let's say an array int Can I do that? Let's just say there we go. Let's just call that old. Let's call this new. And so what's happening here? We're gonna, let's just say we're gonna redirect. Let's close the old, and this should be either 1, either 0 or 1. So we're either going to be redirecting redirect standard in or standard out. That's all, and we can even force that if old does not equal one, 0, and old does not equal 1. Let's just return. So you won't run into any bugs there. And let's close. So we closed that file descriptor. So we then closed the file descriptor either 1 or 0. So that one's now free. Now, by calling the dupe with new old. So what's happening there is we're just, if we close the read end of the pipe, we're gonna duplicate the read end of this pipe, and we're gonna redirect the standard read to the standard in to the read end of that pipe. And if it was 1, we would just let's actually, it has to be there. And if it was 1, well, we would be redirecting, we would close 1, the standard input, we would redirect the right end of this pipe to standard input, and now, remember, we can close new old. That sounds really weird, but whatever. There we go. Because we don't need that pipe. We don't need that reference to the open pipe anymore. So we can just close that. And there we go. And so then, what's another another thing that we want to do? Well, let's start writing our program. Let's get into the fun old stuff. There we go. So let's say, remember, we want to create a pipe. So this is in this main process. We want to create a pipe. So int process descriptor 2. All right, there we go. And so let's say in parent. So parent process, if fork, and then else, and then there's the child process. So what do we want the parent process to do? We want to redirect the standard output into and also I forgot to call pipe process descriptor. There we go. Redirect. There we go. And so let's go back to our diagram, our good old fancy diagram here. And so what are things looking like? So we created a pipe. We don't have a child process. We'll just ignore that for right now. And so in our process, we have we can just close that read end of the pipe, right? We can just close that so this is what it's looking like right now. We have going to the right, we've redirected standard in, we've closed, there we go, we've closed that reference to the right end of the pipe. Pipe's still open though because we have one reference to it. And we can close the read end, that reference to the read end of the pipe, so because we won't be reading from it. So we can close PD 0. Boom. Easy peasy lemon squeezy. There we go. We close that. And so we've redirected everything. Anything else? Should we close anything else? So that's the question. That's the question. Should we be closing anything else? Well, we don't really want to close standard in. We don't want to close standard out. Not yet, at least. And so let's just, we can just call source. And let's actually just get from, let's just get n from, let's just get that from, what would we call? From the terminal argument. So let's just go int n equals atui argv1. Okay, man 3, I think, atui. And in standard library, include, let me just copy that. All right, that just says, what is it? What does it even mean? So it just converts the first argument, well, the first argument passed, which is argv1 index, weirdly enough. It's fine. And converts that to string. Let's just pack in and boom. There we go. So we'll print out, we'll just direct, and then we can close standard output. There we go. Everything should be closed by now. So let's close read end of pipe. Let's redirect standard output to right end of pipe. And let's into right end of pipe. There we go. And there we go. And then close pipe. Close right end of pipe. Perfect. And we should probably wait for child to do its thing. We'll just wait for a child. There we go. And what does the child want to do? Okay, so this is where it gets a little bit little bit interesting. So let's create another void found prime And we don't need to pass any arguments. Always forget to do that. And it's even, Okay, so what is this prime going to be doing? All right, so we're in the child process. And so let's say let's update these things. I think I messed that about a little bit. Let's go into process 2. Boop, standard error, standard output, standard input. There we go. Reading end and pointer 4. And well, pointer. Did I delete that? That's annoying. That's fine. 3 is just pointing to the read end. So that's what our pipe looks like. And so that's fine. So but remember, this is where things get a little tricky. Little tricky. We want to redirect the read okay. And then we can just close process descriptor 1. That's fine. We can close the right end of the pipe. We can close right end of pipe. And then we can call found prime. And so what is that function going to do? And well, then we can close process descriptor 0. No, process descriptor 1. Let's close 0. Close the read end of the pipe. Alright, there we go. And so so we found a prime. What do we want to do? What do we want to do when we found a prime? Well, we first want to, so what does this child process want to do? Let's go back to our, not that. Let's go how it works. So we just want the first number, so we want to get the first number and print it out to the screen. So let's then, in that child process, we want to just read int prime. Read, we're just going to read from the standard input from 0, write that the prime and size of int. There we go. So we're just going to read from that prime. And so here's where things get, and then we just want to write that printf to the screen, prime prime. There we go. And we can, so we are not even, we're not going to be reading from this. Oh, actually, we still will be reading from that pipe, so we can't close it. We've closed the right end of the pipe, and so what we want to do, int n, but we want to actually create another pipe to go to that next pipe, and remember that's the first step, int. So let's create another pipe. There we go. And now it's going to look very, very similar. So create a new pipe. Create a new pipe to communicate from what is now the parent. So from parent to child. Okay, and then we can say if fork, because we need another process, parent process, else child process. It's just okay, and so the child process, so we want the parent process to redirect its writing. So we can just, well, remember, we can just close read end of pipe. That's, we don't need close. Process is 0, and redirect standard output, standard out to pipe, redirect standard output to pipe. Okay, and then we want to send, so we want to int n while, so we want to read from the original parent, so the original pipe, the standard input. We want to, so while read so read from 0, we want to get that to n, size of int, and we want to say while it's greater than 0, because it'll return -1 if there's an error, or if 0 bytes were read, it'll return 0 bytes, I think. But we can say greater than 0. While the read end of the pipe is greater than 0, we can then just, so we're getting that, n, if n is divisible, n divided by prime is not equal 0, we can then just write to the standard input write into the standard input, which we have redirected, and size of int. Okay, and that should there. And remember, we're done reading, so we want to close that pipe. we close that process descriptor, we redirected one, close the read end of the pipe. There we go. Oh, and remember, we can now close the read end of the pipe. Not super necessary, but let's do that. And then again, let's wait for the child to finish. And so what's the child gonna do? Well, it's gonna be fairly similar to what it did here. It's gonna redirect rect 0. It's gonna redirect its input. I mean its read. It's gonna close the right end of the pipe, PD1, and it's gonna call found prime again, found prime. And so then it'll just return. And so let's see. Okay, that was. Let's see. I mean, let's see what happened. Did I do any of that right? Primes.c. Okay, well it compiles. And let's say 10. Oh, that's interesting. Well, what do you know? Why did that happen? I know why. Because I forgot to close the last one. So we can say if the read end of the pipe is less than or equal to 0, let's just return. And there we go. And let's say GCC primes. Let's do it for 100. Okay, that's cool. Well, let's see, can it do 1,000? Well, it can. Can it do 10,000? You know, it can. It's not the best program, but like the most efficient. Can it do 100,000?